All right. Good morning, good evening, good afternoon, everybody, wherever you are. Welcome to the Open Science DAO Hall. OpSci is an open science community actively researching and developing web tools for DeSci, or decentralized science. Our key activities bridge a few key aspects of science in Web3. Those are cloud services and requirements for open science commons, research data management with decentralized file storage protocols, reputation, identity, and collaboration for research. And you'll hear a little bit about token engineering to build alternative systems of value transfer and capture that support sustainable knowledge creation systems. So this was made possible by the Open Web Fellowship, which provides support and funding for scholars and developers in between career gaps. And this is primarily to perform basic research or contribute to this growing ecosystem. If any of the above sounds interesting, you can get involved today by joining a working group on Discord or hack.opsci.io, volunteering to join our ranks of Open Web Fellow mentors, or by proposing a research project. Before we get into it today, please do complete the DAO Hall register to record your attendance at this meeting today. POAPs will be issued for each community DAO Hall, and it's being considered as a method for signifying membership and service in the DeSci ecosystem. Make sure you can claim your POAP by completing the survey as soon as you can. We've minted one for each RSVP to the event. Cool. So intros aside, Happy New Year, everybody. 2021, we've all successfully rage quit. Now 2022, forward. So we'll open up today with Jakub's final presentation on his Open Web Fellowship project, Simulations for Science Communities. He'll also introduce DARC-SPICE, which is a toolbox for monitoring decentralized autonomous research communities. You can, if you're interested in kind of seeing the thread of thoughts that led up to this moment, you can go ahead and take a look after the DAO Hall at his midterm presentation. You can find the link to that on the discourse. So today we have just a couple updates, a discussion topic, and then we'll dive right into the presentation. So first, I'd like to announce that OpSci will be transitioning to a California 501c3. And to support this, we're announcing the formation of a legal engineering working group. We do have a very talented set of attorneys that are kind of working to really address all of the legal intricacies of building out a DAO and having it legally compliant and actually being able to do meaningful work and build meaningful relationships with institutions, foundations, and also to receive accreditation for the sorts of things that an academic research institute might do. So this is just a small step forward in this vision of a decentralized Web3-based university. And along the way, we're really exploring DAO-to-DAO opportunities for the OpSci community. So a lot of what we do is building really basic, low-level, low-lying DeSci stack components. And I mentioned a couple of these earlier, like decentralized storage, identity, archival mechanisms, and just stress testing a lot of this technology out there that's out there already and seeing what really pans out. All of this is a huge experiment. So I think there's two really, or three really kind of major DAOs out there that are involved in science. One of them is, of course, DAO, which has really kind of broke ground with their really unique method for raising funds and generating just unparalleled interest for scientific research in Web3. There's LabDAO, which is, you can think of it as a Craigslist for wet lab scientists, and I think we have a few folks from LabDAO here today. I'm sure they can jump in and elaborate a little bit as well. And we have some other DAOs too, like Open Access DAO, which started off with kind of a meme of buying all the research journals. So I would encourage the community to think about how we could build tools that transcend just a single use case, but really kind of pave the way or demonstrate unique elements of Web3 that can empower decentralized science communities, where we can just fork a framework and use that to kind of develop very specific use cases, whether it's for wet lab biology or for novel fundraising, or for, in the case today, simulating different types of science token communities. So with that, I would like to transition to working group updates. I'm going to take a quick peek to see who's in the call today. I see Caleb is here. He's the steward or the lead on the decentralized file storage working group. Caleb, how are you? Okay, we'll circle back around to you.
Hey, sorry.
Oh, you're good. Did you want to give a quick update?
Yeah. So all the articles in that little series on decentralized storage are out on Pulse. And we're planning on having a little meeting probably this weekend to talk about all of those. I'm thinking we'll do probably something like maybe 10 minutes, and I can just give an overview of the ecosystem there. And then depending on what the interest is, we could go into more specifics, questions, stuff like that. So, yeah.
Cool, awesome. Yeah, no, we've been talking, there's been a lot of interest in exploring some of that, some of the content in more detail, specifically consequences for how we might think about science being done with that technology, and as far reaching as institutional trust, whether it's there yet, as as just kind of menial as, does this stuff actually work yet? So, it would be great, I think, to do a Twitter Spaces or just a Discord stage session and kind of really disentangle those. So if you're interested in participating in that conversation, please do fill out the survey that Caleb has posted in the working group on Discord. And we can find a time to all get together. Cool. So let's see, who else do we have here? I don't think I see Akshata. So I don't have any updates from her this week. Kinshuk is on campus, but I'll give an update in his stead. So Kinshuk's been putting together a Unix pipeline for pulling data from metadata aggregators like DataLad, which indexes about 256 terabytes, probably a little bit more than that, of neuroimaging data that's open access. And the idea was to use this index to kind of get a quick survey and build up a metadata database of all the neuroimaging data that's out there. As we went through it, we found that there was a lot of patchy holes in the coverage of that data set. A lot of the data kind of dropped off. You'll download a data set and you'll see individual files missing. And so this kind of really just reinforced our use case really was to permanently archive a lot of this data and make sure that it's not only content addressable, interoperable, and follows certain validation schemas so that you can run applications out of the box without looking at the data, like, for example, with BIDS apps, if anyone is familiar with those. And so Kinshuk's put together a really nice pipeline. It's on the GitHub under OpSci. It's called DeSci storage. You can go ahead and take a look at that. And the goal is to kind of start with that as a proto pipeline and start archiving a lot of this massive data on Filecoin Plus, which provides free archival for high value data. We have a relationship with Protocol Labs and are in the process of applying for our own Filecoin Plus notarization. Right now we're using Estuary as a stopgap to store this data. So that's coming together really nicely. Really, really excited about that. I think also, I think Achi is in the call as well today. Achi, did you want to give any updates on some of the research you've been doing on governance work?
Hello everyone. So I've been working on the OpSci DAO tutorial and the client that we can work with for governance and rewarding the contributors and stuff. So I've researched. There are a couple of clients such as the one hive client called Gardens, and coordinate and Aragon that we are focusing on right now, and bunch of other DAO kind of a framework for a framework for a DAO that we can use for governance and rewarding the contributors. So we have currently been working on making the tutorial for using these this framework. So if anyone wants to review and chime in, they can and they can contact me on Discord. That's all.
Yeah, I think there's some really exciting opportunities there. So we're considering in 2022 early transitioning to using Coordinate. I had the privilege to really see it in action with LabDAO. It was pretty cool seeing it all kind of come together, tracking contributions. So the way that works is you start a circle and everyone's given 100 give tokens for work performed during an epoch, and you set that up. And at the end of the epoch, everyone kind of decides how to divvy up their give tokens to everybody else. And of course, the give tokens are just ethereal points, no pun intended. But you could set it up in a way so that that you can cash them in or exchange them for a particular token or for whatever token really. So I think that's really interesting, especially when combined with, for example, giving out governance tokens in a way that matches the contribution effort that's put in by the individuals, and it's more community sourced. So it kind of really makes us think about what a fair launch could look like from a bootstrapping perspective. So I think that's really exciting. It doesn't solve all the problems with governance, of course. That's why we have tools like Aragon and Gardens as well as things to look at. Cool. All right. So yeah, so we're going to be looking at that. I'd like to just spend a couple minutes to really meditate on this month's discussion topic that's really inspired by some of the work that Ivo and Kinshuk have been doing, thinking about, and myself, thinking about identity and how all of the applications that we might build on a DeSci stack are going to come down to tracking contributions and identity. Did anyone have something to say? Okay, sorry about that. I thought I heard someone speak up. Yeah, so this month's open conversation thread, and feel free to raise your hand if you have something to say, or if you would like to go ahead and shoot something in the chat message, in the chat box. How do we transcend legacy academic credentials in Web3? So, what I really mean by this question, or what we really mean by this question is, how do we move beyond these legacy, I guess you could call them like indicators of expertise or access or pedigree, such as the PhD, right? And challenging ourselves to think beyond just a degree that's a great point. Moving beyond kind of rewarding people for work done, but thinking also about what kind of quantitative metrics and what would a portable identity look like. So kind of thinking about a user profile that scrapes data that's relevant to the contributions a person has made, not only for open source, but also, we have someone join in, but also for paper reviews, data cleaning, mentoring, and that sort of thing. And really taking impact stories as a point, a starting point there, which is an NIH endorsed method for tracking contributions. And it kind of came about this need to, or this really idea within the open science community to propose badges as a way of tracking contributions that go beyond just like a paper publication. So we'll be exploring this this idea in more detail. There's some like rough schematics of what it could look like on the discourse. And we'll be exploring it at ETH Denver as part of the hackathon. If you're interested, do reach out. We do have a limited number of travel grants for anyone who wants to attend in person. So do let me know. And I would like to open up the floor to anyone who would like to chime in.
So hello, I'm Nicolas Lepera. I go by Nikete, and I had some questions about a few of the bits here. So I guess the first question is, where is I tried looking at the website, but where is the current funding come from, and what commitments by whom have been made?
For the project, for the identity project?
Yeah. For the project, yeah. So you've spoken about grants, and I saw that there were some fellowship applications. So I was wondering, like it was like, yeah, that was a big.
Yeah. So OpSci, just for full transparency's sake, OpSci is funded by both Ocean DAO and Filecoin Foundation. We both have contracts of work with both of those organizations. And as part of that, we've set aside some cash to fund fellows at the undergraduate, graduate, and in-between levels. And you don't have to have a college degree or anything.
So the question is, so is there an entity that signed those contracts? Did you sign those contracts?
Yes.
I'm just
Absentia Ltd signed those contracts. Yes, they're all legal agreements. Yes.
Yeah. I mean, the question was, what were the parties of the agreements? Okay, so this development. So is there like a, so in this DAO there will be some kind of governance that, like, there's like some research now into how to structure that, and what's the starting, like, are we providing transparency to people that want to, like, think about contributing to this, about like what commitments have already been made and what commitments are still flexible? Are these all grants, the current funding?
Yeah, absolutely. I mean, the major, I think, kind of qualification or constraint, I don't think of it as a constraint, I think of it as a perk of these grants, is that all of our work is open source by default. So everything that we publish before the end of the performance period have to be made accessible for anyone to use. And so we seek to publish things as we move along and as soon as they're ready. But yeah, I would love to kind of dive into this conversation a little bit more. I think a great way to kind of get an idea of what's happening is to join these meetings, and we could talk about structure and different opportunities for contribution. So we're actually transitioning to a nonprofit. The parent organization right now is it's a limited liability based in Singapore, but we're transitioning to a nonprofit based in California now, and we'll be publishing the bylaws for that organization very shortly. If you have any questions or you're interested in helping to form what that looks like, more than happy to hop on a separate call and we can talk about that. And I can loop everyone that's involved in together.
Yeah, sure. I might have some vague suggestions, but
yeah, that would be awesome. Cool. And I think you introduced yourself as well. Did you want to give just kind of a bit more introduction, Nicolas, before we transition to Jakub's talk?
Yeah, of course. So I did undergraduate degrees in economics and computer science. I did a PhD in a machine learning group where I studied how, like, mechanisms for collective cognition at some level. So originally, a lot of these applications come originally from crowdsourcing. So how do you incentivize people to provide information that is costly for them to acquire when you don't have access to the ground truth, or when the people might need to experiment on themselves or on resources that are scarce for them in generating that information. So I did some work there, and I guess, like, I mean, I do have a degree in economics, and I worked for a decentralized exchange and a web-free, like, monetize your data, like tokenize your data in the previous cycle companies. So I have like some experience in the sector.
Oh, that's amazing. Welcome to the community. We're super stoked to have you here. That's amazing.
Oh, and one time I did a random, like an open science randomized control trial where we intervened on a very early token exchange called Cryptsy. So we placed like 300,000 trades at random to see how we could perturb the prices in the market.
Oh yeah, I think you're gonna really like what we have in store today. So I would like to transition to Jakub's talk, so he has enough time to kind of share all the exciting developments he has lined up for you. Quick intro: Jakub is an undergraduate, a very talented undergraduate, studying maths and physics at Fordham University. He came to us last semester with an application to study value flows in scientific communities and how we could use tokenomics or token engineering, as it's becoming known as kind of an emerging field, to proactively model and build value capture mechanisms for scientific communities, where the underlying value are knowledge artifacts that are exchanged transparently and out in the open, backed up by blockchain technology. So I don't want to delay anymore. Jakub, please feel free to take it away.
Thanks, Shadi. So hello again, everyone. Today, I'm going to present my journey in the Open Web Fellowship. As Shadi mentioned, its focus is on science token communities, which essentially means looking at current science value flows, identifying the problems with it, and then trying to design alternative models within Web3 that might solve some of these problems. So before I get to some of the models that were developed, let me first go over what the problem with the current science value flow is. So the schema on the right shows a kind of simplification of the current science value flow, where the value starts in some centralized grant funding agency, and you might argue the money from that agency came from somewhere as well. But when we take the science value flow without any external actors, it is sufficient to say that funding starts in some grant funding agency. This agency then disperses funding to either individual research groups or other centralized entities like private research organizations or universities, which also employ researchers. And then these organizations disperse the funding to individual researchers, who then transform this monetary value into new knowledge. And this monetary value is used to cover the research costs, getting data, paying grad students, and publishing to scientific journals. And so this knowledge value is then sent to these scientific journals. Of course, you have to pay in order to publish to most of them. And in this way, we can see that the science value flow is very linear. Value starts in one centralized agency and then ends in another one. And this linear flow of value is really an issue, because when we think about what the goal of science is, what the objective function of science is, it's really to expand human knowledge and to use that knowledge to improve our lives. And scientific knowledge has the greatest value only when it is spread across as many people as possible. So in a way, we would really like to have a system which is self-sustaining. And this value flow currently relies on external injections. So unless the grant funding agency is going to get injections from philanthropists or governments, it's eventually going to run out of funding. And in the same way, journals, even though their role is knowledge dissemination, because they are private entities, their incentives aren't necessarily aligned with the objective function of science, but rather they are because they're holding a lot of knowledge assets, they can set the barriers to access to those knowledge assets through paywalls, for instance. So that leads me to another problem in this value flow, which is centralization of value. Value starts at one place and ends in another place. And it's really a unfair distribution of value, because if you think about it, it's the researchers who are actually creating all of the knowledge assets and who are expanding the human knowledge base, but they are reliant on these centralized agencies, whether it's journals, so that their work is spread across the scientific community, or a university, which gives them some security in the form of a monthly income, or grant funding agencies for funding. But this reliance on centralization has certain trade-offs. For instance, researchers, because they are employed by some centralized agencies, don't retain full ownership of the knowledge assets they create. So even if a researcher would want to publish an entire data set for anyone to use, they don't necessarily have the right to do so. But actually, the system is set up that it doesn't really incentivize collaboration and data sharing between researchers, because gathering a very useful data set takes a lot of time, it takes a lot of money, and it represents some kind of intellectual property that gives you a competitive advantage in subsequent research projects. And giving that away isn't really an option if you want to have a long-term scientific career. So what frequently happens is that researchers publish the bare minimum of their results to get past peer review. And most of the knowledge assets that are produced within this science ecosystem aren't even published. So not only are knowledge assets locked within centralized agencies, either in the form of IP that's controlled by a university, for instance, or a journal that owns scientific papers, but most of the knowledge isn't even shared in scientific journals. It's locked away in data silos that are almost never used. So this is really the motivation behind this Open Web Fellowship, trying to design alternative value flows that would solve some of these issues, like the linearity of the value flow or the centralization of value, and overall the reliance on centralized agencies for both funding and scientific dissemination. So for this, I was using the token-SPICE simulator, now called DARC-SPICE, which is essentially a fork of token-SPICE containing all of the simulations that I'm going to talk about in a minute, if you want to play around with some of them after this DAO Hall. And token-SPICE was originally developed as a general smart contract validator for Ocean Protocol, but now it has become a very general agent-based simulator where you can simulate pretty much any type of economic value flow. So you only really need to design the logic of different agents and then connect them in a script called a netlist. token-SPICE was inspired by analog circuit design. If anyone is familiar with SPICE, that's where the name came from. And in token-SPICE, we can really track pretty much any type of metric we want. So in our case, we are interested in how many projects we can fund. We are interested in the value flow. So is the value distribution fair? Also, is there some kind of a feedback loop that at least contributes to some kind of sustainability in the long run? And a lot of other metrics that we'll get to. So with that, we can take a look at the models. So the first one is the one we've looked at before. It's the baseline model. And in this baseline model, the main agents that we are concerned with are the researcher agents and then the university agent, which, so the researcher agents publish research proposals, which are then evaluated by the university. And the university then disperses funding based on some underlying logic to the researchers, who then use that funding to create new knowledge assets and publish them to journals. And the key thing is that this value flow is still linear. Initially, the research proposals are initialized randomly, but the key metric that determines whether a proposal is accepted or not is the knowledge access index, which in this case can be thought of as researcher reputation. So the simple logic is the researcher with the higher reputation is more likely to get funded than a researcher with lower reputation. And the researchers start with the same knowledge access index. And the way to get more reputation is to do more research and publish research papers. So it's a very simplified version of what the science value flow could look like, but it serves as a pretty useful baseline. So here are the graphs that were generated by the simulation. And essentially the top row is showing the same thing, which is that this mechanism leads to a kind of winner takes all system, where even though at the first step we have the proposals are initialized randomly, so it's completely random which researcher wins the first funding round. The one that does is then very likely to win all the subsequent funding rounds. And in this run of the simulation, and in most of the other ones as well, a single researcher was always an absolute winner of pretty much all of the funding. And because of the centralization of value, it is the idea is that it's difficult for the other researcher to gain access to the knowledge that's produced by the first researcher, hence the name knowledge access, because the incentives are misaligned and researchers aren't really incentivized to collaborate and share data. So the first researcher always has a very large competitive advantage. In the bottom row, we can see that we have some centralized grant funding agency that eventually loses all of its funding, and in the bottom right plot, all of the funding eventually ends up in a centralized agency. Now it says sellers, but it should really say journals. And just so I get the terminology right, it's not necessarily funding, but we're talking about value. So the orange line in the bottom right corner doesn't necessarily represent the monetary value coming from the university, but it represents the value of the knowledge assets that have been published. And so that's showing the problems with the baseline model that I talked about before. Now, this model clearly has a number of limitations. First of all, it's very simplified. It also has fixed parameters. So in this model only supports 2 researchers. The assets have fixed price. The logic is very simple and quite naive. And there aren't that many metrics that we are tracking. This model is mainly, it should mainly serve as a baseline for the development of subsequent models, and also for a kind of simple validation of the problems that we have identified. And some future development will focus on making this model with a higher resolution that would more accurately reflect real-world data. So for instance, in this model where we have the winner-takes-all mechanism, is analogous to what happens in the real world, in that researchers that have been funded previously are slightly more likely to get funded in the future, but it's not really reflective of that, because obviously there are still many researchers that propose new research projects that get funded, and it's not necessarily a bad thing that researchers that have been funded previously are funded again. So again, this model is really a simplification. That leads us to the next model, which is the first of the series of the Web3 inspired science value flows. So in this model, we have taken the scientific journal and we have transformed it into a decentralized knowledge market. Now, the decentralized knowledge market tries to solve some of the problems of scientific journals, and it's mainly inspired from by the ocean market, which creates this new data economy, but it's more generalized towards an entire knowledge economy. So the knowledge market collects transaction fees whenever a researcher tries to buy a data set or buy access to a paper or an algorithm or any kind of knowledge asset. So we are trying to create this kind of value feedback loop to the treasury to reach a sustainability point. Other than that, the proposal mechanism is still the same as in the baseline model, but now this model is a bit more high resolution in that we can initialize it with an arbitrary number of researchers, and we are tracking more metrics as well. Another key difference is with the knowledge access index. This being a decentralized knowledge market, it incentivizes anyone to publish as many results from a research project as possible. So because you can set certain privacy restrictions, you are really incentivized to publish pretty much everything you create. So entire data sets may be published to the knowledge market, and they can be used to train machine learning algorithms, for instance. So it's much easier for researchers that aren't funded to gain access to the new knowledge, and therefore maintain the same level of competitiveness as the researchers that have been funded previously. And also, researchers retain ownership of any assets that they publish to the knowledge market. So here we are trying to alleviate the need for centralized agencies, in that researchers are reaping the benefits of the assets they produce over time as new researchers come and they buy the knowledge assets, and that money goes to the researchers that produce them. So these are the plots for a simulation with two researchers. We see that the problem of the winner-takes-all mechanism has been solved, and both researchers are getting funded over time, and they are maintaining the same knowledge access index as in the plot on the right there. Also, you can see that the researchers are getting some form of a passive income in the top right plot. And while we have not really reached a stable equilibrium point where the system would be self-sustaining, the treasury plot is slightly skewed because of the transaction fees. But since the transaction fees are not really that high, and they shouldn't be, and we only have 2 researchers transacting, we don't really reach a point where enough value is flowing back into the ecosystem, and the researchers are also not buying any more knowledge assets than they need from the knowledge market, and they are keeping all of the tokens that they receive from the knowledge market, so they kind of lock all of the value as well. So in short, we have not really reached an equilibrium point. We also have a staker agent in this simulation, although it's not really that important. It's only there really to provide some type of liquidity and to show that in a decentralized system, we can open science to a whole range of stakeholders, and we can have this kind of open science economy as well, where speculators could stake on certain knowledge assets and on their success or impact in the long run. And also the bottom right corner plot shows the value that's encapsulated within the knowledge market, but this also just represents the value of the individual knowledge assets. I also run this simulation with 100 researchers, which did manage to maintain this value within the treasury for 30 years. But at the same time, because we are only funding one proposal at a time, there have inevitably been researchers that haven't been funded and have lost all of the tokens that they were initialized with. So this is more of this is showing some of the limitations of this model, where we are only funding one research project at a time, which leads me to the next iteration of the profit sharing model with multiple proposals funded. Now, this is the exact same model, with the exception that we have multiple proposals funded at a time, and that inevitably leads to the treasury exhausting its funds quicker, because at each funding round, it needs to disperse more funding than previously. And if we have a limited number of researchers, there's really not enough transaction fees to reach a stable equilibrium point. Other than that, the functionality is very similar to the first profit sharing model. All researchers are getting funded. And actually, in this model and in the subsequent models, we are actually guaranteeing that unless there are, say, 100 researchers, at least all of the researchers are pretty much guaranteed to get funded at least once, because when in this simulation where we have 5 researchers and 3 proposals funded at a time, the 2 researchers that aren't funded initially then have 3 research projects that they can catch up on within the knowledge market. So their knowledge access index is then going to be higher than the knowledge access index of the researchers that have been funded. So in the subsequent funding rounds, they're almost guaranteed to receive funding. These are plots of another simulation with 10 researchers. I don't think there's anything too different in these plots, so we can go ahead and skip through this. So the next iteration of the profit sharing model introduces funding on a rolling basis. So this is again just increasing the resolution of the model. Initially, we had fixed funding rounds where each research project would take the same amount of time, which is obviously not realistic. So this is now this is now within the research proposal, where the researchers also set the time frame of the research project, and if they get funded, they will not ask for another funding until they finish the research project and funding is rolled out on as research projects finish. So this is just adding a bit more resolution to this model, but other than that, it's exactly the same model as before. So the plots look very similar, except they're not as regular because of the rolling basis funding. In this model, I've also experimented with random buying actions for the researchers, where they could randomly buy a knowledge asset from the knowledge market. This didn't really show anything. It's still, the option is still available in the simulation if you would like to try it out, and maybe it's something that can be explored further. But it was, the idea behind it was that perhaps as researchers are getting more income from the research projects they produce, they would want to randomly buy new knowledge assets from the knowledge market, as because there are multiple proposals funded at a time. So for instance, the researcher that is being funded would want to also buy access to the knowledge assets produced by the other two funded researchers. But this random buying made the graphs not really readable, as you can see here, where we couldn't really, there isn't really much to deduce from these graphs. There's a bit more fees collected because there's more transactions being done. But it still didn't really create a sustainable system where enough transactions would be collected to make the system sustainable. So now we get on to the more, hopefully more sophisticated models. The first one being the public funding model. So again, we are going from the profit sharing model, but now each researcher is either a data or an algorithm provider. So a data provider is collecting new data sets. Algorithm provider, you can think of it as a theoretician creating new algorithms. We are also distinguishing between a public market and a private market. The idea behind that is that even private entities would benefit from a decentralized knowledge market where more data is being exchanged, and so they could either get more rewards for the data that private organizations currently own. That's in the form of a compute provider. So an organization that has a data set that's so large that it doesn't really make sense to publish to a knowledge market, but they provide access to it through compute services. So we could create this decentralized cloud computing service for science. And overall, just private entities would also have incentive to participate in the knowledge market, either for buying resources or for sharing resources. That's really open to discussion. Now, the researchers that are funded by the DAO Treasury are public researchers, so they don't retain ownership of the knowledge assets they produce beyond some recognition for their contribution. So that's why also the funding includes includes the salary of the researchers for them to be able to sustain themselves. And the idea behind the public knowledge market is, again, that knowledge really has the greatest value when it is shared among as many people as possible. Therefore, it might be a good idea to consider it as a public good. And so the question is whether we can create a decentralized system that funds public goods, either retroactively or through some other means, and whether that system could be sustainable. And actually, this was one of the more successful models where, because we had injections from private entities and the contributions from the private knowledge market, even after 30 years, there was still funding available within the DAO treasury. So this model is the most sustainable one, even though the graph is still skewed. So it's not really, it wouldn't be sustainable. It wouldn't be sustainable for, say, 100 years, but 30 years is a pretty long time. However, this model still has some limitations. So, for instance, the private researchers don't really get the benefits that they would expect from publishing to the private knowledge market. So they're really only there to provide injections to the ecosystem. We're also tracking the value that's encapsulated by private and public markets and the fees that are collected there. I forgot to mention that the public market doesn't necessarily mean that everything is free, but all the knowledge assets are heavily subsidized, so they're very cheap compared to the ones in the private market. And this simulation can be modified with different prices for different knowledge assets. So for each type of researcher, there's also a type of knowledge assets that can be bought from the knowledge markets. So data, algorithm, or compute services, and each value, the value of each service can be set before the simulation. So the simulation is slightly more modular than the previous ones. So
Jakub, just to give some time for, because we just have 2 minutes left at the top of the hour, and I want to be respectful of people's times. Would you like to maybe wrap it up? And then if there's anyone hanging around afterwards, we could go through the rest of your slides.
Yeah, sure. So basically, the last two models were iterations of the public funding model with a lot more metrics and slightly more functionality, such as the growth of the research community or the introduction of the community agent and overall higher resolution. And then I just wanted to conclude with some plans for the future, where we want to update DARC-SPICE and the CLI, increase the resolution of the baseline model, maybe even include variations of it. And just to tie everything together, this research falls within the research of the objective function of science, because we really need to determine what the objective function of science is in order to design incentives that fulfill it on both the individual agents level, so for the different stakeholders that are within the ecosystem, and for the ecosystem itself. So that's an open research question. And another point for further development is adding reinforcement learning agents to the simulations within DARC-SPICE for better validation of the models. Because one vision for DARC-SPICE is for it to become kind of an OpenAI gym of Web3, where now we have a number of different environments that have agents with fixed logic, and logical next step is to remove that fixed logic and add agents to the environments that can learn themselves and perhaps uncover some further limitations of the models. And if anyone wants to contribute either to DARC-SPICE or to the research of objective function of science, you're definitely encouraged to do so, and feel free to shoot me a message if you want to, if you have any problems with setting up DARC-SPICE. There's definitely a lot of development ahead, and it's going to take the efforts of many to make something out of it. So thanks everyone for listening.
Awesome, Jakub. We have some questions in the chat. I know we're running a little bit over. If people want to hear the answers, please do stick around. So the first question is, I'm going to just go from the top. What were some of the design decisions that you made to choose tokenized instead of building a model using CAD?
I think, well, that has a pretty simple answer, and I didn't know about CAD before starting to work with tokenized, so that was pretty much the reason for using tokenized. And I started attending the tokenized weekly hack sessions, where I learned more about it, and I was kind of once I started working with it, I didn't really have the need to switch to CAD. And CAD and tokenized are quite complementary, so I don't really have experience with CAD, so don't really take my word for it. But I think that tokenized provides bit more degrees of freedom in terms of the development of the agents.
Cool. So Nicolas also pointed out that in principle, it might make sense to eventually implement things on both CAD and tokenized to check your code and your formalization, make sure they match up.
Yeah, that's a great point. I think I've been meaning to dive into CAD, so hopefully I'll get a chance to maybe recreate some of these models in CAD soon.
Next question, is there a mechanism for improving data cleaning, peer reviewing assets on the knowledge market?
So that's something that's, I don't know if those are two different things. Peer review is something that we have been thinking about, how it could be implemented in tokenized. And there's a decentralized protocol called Ants Review. I don't think that it's currently in development. But there might be some mechanisms that we might try to implement in tokenized for peer review. So again, maybe some form of bounty, creating some kind of bounties for peer review, and maybe some separate agent which would store the proposals, and then researchers could interact with this agent to provide peer review, and then get some kind of either monetary or non-monetary rewards. But yeah, peer review is definitely something to consider.
Yeah, I think this makes sense with the community agent model. But you can, I think you'll be posting a blog post soon, so people can learn more about that. Just the tip of the iceberg here. So a couple questions from Active Inference Lab. Knowledge access is same and complete for everyone if the research is open source. And how does value get assigned to atomic units of research of different scale when the impact value is situational or non-fungible?
Well, I'd say that for open source projects, the knowledge access would be the same. The question is whether I'm not sure whether open source project necessarily means that all of the results are published. If they are, then I definitely agree, and that's something that's a very similar mechanism to what the public funding model is trying to model. I'm sorry, what was the second part of the question?
The second part of the question, and maybe Ocean Protocol is a part of this answer, but I'll let you answer. How does value get assigned to atomic units of research of different scale when the impact or value is situational or non-fungible?
Yeah. So that's something that I've been working towards with the model I just skimmed. So currently, the research projects are pretty much randomized. So apart from the knowledge access index, the funding requested, the impact of the research project, its novelty and integration, which are some of the new metrics that have been introduced, these are all random. And in the newest model, the research project is essentially a class that lives on even after the research is done. And I'm trying to track its value over time through engagement with the community. So I think that some of the metrics that are currently in place, like citations, are pretty good metrics when it comes to the impact of a research project. I think the misalignment of incentives is when the metric becomes the goal. So when the goal is increase the number of citations, we get behavior in the systems that we don't necessarily want. Like it's interesting. I read this article recently that the number of occurrences of the word innovative has increased a lot in the past decade or so. And now the question is whether researchers are now more innovative than, say, 20 years ago, or whether the system is currently working in a way to incentivize artificial inflation of the significance of a research project. And so I think it's still something for further research, but one way I try to track value of a research project over time in DARC-SPICE is through, for instance, engagement with a research project after it has been published to the marketplace, either from other research agents which are using that research project for their own research. So hopefully, in the near future, we'll be able to track some academic lineage, and also with engagement with the community agent, which may be indicative of how well that research project is communicated with someone with a non-scientific background. Although it's still very much a simplification, but we're slowly getting there.
Awesome, great response. So I think this last question here is pretty important, considering all the different models we've talked about, and that is which parts of the research, for example, raw data, curated data, analysis, publication, are available for free? If it's all for free, where does money enter the system?
Yeah, so I don't think that any of them are necessarily for free. At least not in the models that I talked about. It's more that it's in the public funding model. So the the public research projects are just cheaper than the private research projects, but the agents still have to pay to gain access to them. So we've been thinking about this in terms of other public goods, and especially how public goods can be funded in Web3, which can be, for instance, retroactively. So if we have a reasonably good way of measuring the positive impact of a research project, we can retroactively fund the researchers for their contributions, even after they have received a grant, which included their salary, for instance. So since it's, I mean, at the end of the day, all of the simulations are pretty much just transactions, and it's hard to really mimic the the very high resolution scenarios of when a research project is, for instance, unsuccessful, or when a research project lasts decades and may have value only down the line. So yeah, I think that hopefully the research projects would have would create enough value to attract even more people to the knowledge market, and just overall create more value than they started with.
Awesome. Thank you for the answers, Jakub. There's one comment here by Ali. I'll leave that to you to parse through. I know that we're 12 minutes over. I know there's still quite a few people here in the room. I'd like to open the floor to any questions if anyone has any.
Yeah, sorry for running over.
Yeah, so if there's no questions, please do make sure to complete the DAO Hall register to claim your collab for attending today, and do RSVP for the next DAO Hall, which will be taking place on 18th of January. The agenda is yet to be set, so we'll stay tuned for updates on that. And I would just like to say a big thank you to Jakub. It's been an absolute pleasure to mentor you through this project. It's been great seeing kind of your growth going from 0 to Web3 hero in a matter of 12 weeks, which has been very inspiring. And I'm really looking forward to seeing how all of this really plays out and comes together. For everyone, I really encourage you to keep your eye out for Jakub's blog post, which will be posted a little bit later today, and kind of kicking off an article series on the objective function of science, along with regenerative economics for token science communities, answering some of these difficult questions, like, you know, what if everything's for free, where does the value come in from? And, you know, can anything really truly be completely for free? So maybe some interesting engineered solutions around that. I'm really excited to explore all of that with you. So please do reach out to us if you would like to get involved. The Open Web Fellowships will be announced for Q1 in the coming weeks. So please do keep an eye out for that. And yeah, and hope to see you at the next DAO Hall. Thank you again so much, Jakub.
Yeah, thanks everyone.